Hello. So in this video, we're going to actually start finding some antiderivatives, or if you prefer, finding some indefinite integrals. Two different ways of talking about basically the same thing. So the bad news, and I'm going to just say this, finding antiderivatives is a lot harder than finding derivatives. In fact, it's very easy to write down functions where you just can't find the antiderivative by hand. Um, Having said that, there is good news, which is that in this applied calculus class, we're going to be missing a lot of the really difficult material. We'll learn some formulas in this section, and then we'll learn one, possibly two, techniques, and that will be it as far as finding antiderivatives goes. So, the rules for antiderivatives are just the derivative rules taken in reverse. So for example, we've said that the derivative of a constant times x is just the constant. This gives us a corresponding integral rule. The integral of a constant is the constant times x. And we'll take care not to forget our constants of integration. Our next rule is the power rule in reverse. When we use the power rule, we decrease, to take a derivative, we decrease the power and then multiply. For the antiderivative, we're going the other way. So we increase the power and divide. The derivative of e to the x is e to the x. If we go the other way, the integral of e to the x is e to the x. Again, with a constant of integration. Finally, the derivative of the natural log is 1 over x. Here, there's a slight kink, or a slight hitch, or whatever word I'm grasping for. When you take the antiderivative of 1 over x, you expect to get the natural log, and you basically do, but there's an absolute value in there. The integral of 1 over x is the natural log of the absolute value of x plus c. And that's because if you're looking at the fraction 1 over x, x could be negative. But we can only take the natural log of positive numbers. So we put an absolute value around the x to make it be positive. In addition to these rules, we have the following. The integral of f plus or minus g is the integral of f plus or minus, let me make sure to write that dx in there, plus or minus the integral of g. This is true for derivatives. The derivative of a sum is the sum of the derivatives. And it's true for antiderivatives. Furthermore, the integral of a constant times a function is the constant times the integral of the function. Let's do an example or two. Perhaps just one, since there are plenty of examples in the textbook, and this is, after all, only intended to supplement the textbook. So the sum rule says that, if we're integrating a sum, if we're integrating, in this case, x squared plus 3 times e to the x, we can just integrate those separately. So this is the integral of x squared plus the integral of 3e to the x. I do have one comment related to constants of integration, but for the moment, let me just work this through very literally. To integrate a power, to integrate x squared, we increase the power by 1, so x cubed, and then we divide by it. 1/3 x cubed. And according to everything I've said, we ought to have a constant of integration. Now go over to the next integral, 3e to the x. According to one of our rules, according to the last rule I gave you, the 3 just pulls out. And the integral of e to the x is e to the x. 1/3 x cubed plus c plus 3. And then according to what I've said, we ought to have a constant of integration. We've already used c, so we use d instead. And we get 1/3 x cubed plus 3 e to the x plus c plus 3 times d, except not really, not exactly. We don't write things like c plus 3d here, because c is just a completely arbitrary number, and d is just a completely arbitrary number. And if we take a completely arbitrary number plus 3 times a completely arbitrary number, we get a completely arbitrary number. So whenever we take an integral, even if there's addition in it, so we're really, taking several integrals and adding them together, we only ever end up with one constant of integration. And the constant of integration never has numbers like 3 attached to it. It's always by itself. So the actual integral, as we would write it in practice, is 1/3 x cubed plus 3 times e to the x plus a constant of integration.